Hi all, welcome to CodAffection. I'm really excited to start this video series implementing user registration, login, authorization. All of these are implemented with Angular Client and ASP.NET Core Minimal Web API using ASP.NET Core Identity Framework and JSON Web Token. In this video, we'll discuss and implement all about user registration or user creation with Angular and ASP.NET Core Web API. In the next video, we'll implement user authentication or login provision with JSON Web Token. And then the following videos will discuss role-based authorization and policy-based authorization, etc. So I'm sure that you will find this content really worthy going forward in your career. So please watch the complete video series. Before starting this video, I would like to ask you a favor. If you find this video helpful, please show your appreciations through your likes and shares. And if you haven't subscribed to the channel yet, please consider doing it now to get notified when I upload upcoming videos from this series. Without further ado, let's get started. So first of all, we are going to design the user registration form in Angular, and then we can implement the counterpart in .NET Core Web API with ASP.NET Core Identity. So let's start with creating the Angular project inside this folder directory. For that, we have to execute an Angular CLI command from this same folder. If you are in Windows, you can do this. Just replace this folder path with cmd, then hit enter, so that this command prompt will be opened from the same folder directory as that of this folder here. Now to create a new Angular project, you can use this Angular CLI command ng new. The name of the app will be auth.ec. Inside this Angular app, we are dealing with the client side, so I will name this app as auth.ec client. If you want to know more about this command, you can go to the official documentation at angular.dev. Inside this references, go to CLI references, and then you can see the command here, ng new. ng new, then followed by the name of the app, will be passed as an argument, and then if necessary, you can configure it further with the options here. All of the options could be seen inside this side panel here. For example, consider the 4 files for the default Angular app component, for which we have the original TypeScript file, it can't be ignored, and then we have the necessary HTML file for designing the component. Rest of these files for style sheet and this test file with the extension spec.ts are optional. So in order to tell the new Angular app that we don't need this component specific style sheet and this test file, we can make use of these options here. So this option here, inline-style, will help you to prevent from creating component specific style sheet throughout the app. Now let me copy this option. While passing the option, we need to use double hyphen as a prefix and then pass the option. For some options, you could see alias like this. Instead of passing this complete option here, we can use this alias small letter s. In that case, we only need to pass a single hyphen as a prefix. Now, in order to prevent from creating component-specific test files, we can make use of this option here, skip test. In short, we can use this alias capital letter S. So here we go, capital letter S. Now finally, in order to skip from initializing the GitHub repository, we can make use of this option. In short, we can use this small letter alias G. Now hit enter. Which style sheet format would you like to use? I will stick with CSS. Do you want to enable SSR and SSD? Press N for no. Wait for some time, it is creating the new project and installing the default npm packages. It will take time based on your internet speed. Finally, here we have done with the creation of the new Angular app. Now let's navigate into the project folder. Now let's open the same in VS Code. For that, you can use this command code space period or .simple, hit enter. So here we have the new Angular app open in VS Code. Now before making any changes inside this new app, let's run this app. So go to terminal, then new terminal, then run this command ng serve, then -o. It will build the project and open the same in your default web browser. So this is how the default Angular app looks like. Now back to VS Code and let's check from where does these default elements are rendered. So here we have the SRC folder. Most of the app development will be done inside this folder. Already installed npm packages and dependencies will be listed inside this package.json file. All of the TypeScript configuration will be there inside these 3 tsconfig files here. And rest of the Angular related configurations will be there inside this angular.json file. Now everything starts from this main.ts file. As you can see, the default app component is used as a wrapper for the entire application. And here we have the index.html file. It contains the HTML declaration and then the head and body tag for the entire web app. Here you could see the tag app-root, which is the selector of the default component, app component. You could see the exact component here. See this TypeScript file representing the app component. There you could see the component selector app-root. The same is mentioned inside this index.html. So in place of this component selector, the corresponding component HTML file app.component.html will be replaced. Whatever is there inside this component specific HTML file will be replaced in place of this selector here. So that's what we have seen inside this app by default. Everything inside this default app is rendered from this component HTML file here. Now you may already know this from Angular 18 onwards, the default app is configured for standalone components. Before Angular 18, by default, the components were organized into modules. So there was a TypeScript file representing the default module as appmodule.ts file, in which we were importing the necessary dependent external packages or services and the containing components inside the module. Instead of components organized into modules, here we have a standalone component. So there is no appmodule.ts file. Each component will import all of the necessary things into its component decorator, as you can see here. So that's a major difference starting from Angular 18. Still, if you want, through changing the app config, you can go back to the previous module-based architecture. Now we have to start customizing the app from this app.component.html file. Now before getting into that, let's talk about the structure of the app that we want to build. For that, I'm going to create a new file. I will name it as app.structure.txt. I have already prepared this structure. Let me paste that here. For now, we are going to create a parent component, user. Inside that, we'll be having two components, one for login form and one for the user registration form. The user registration form will be created inside this video. And then inside this shared folder, we'll be having global entities required for the entire app development, like services and pipes. For now, we'll create this auth service, which is required for consuming the .NET Core Web API that we are about to create. The listed pipe will be created later. Now from this app structure, let's create whatever we needed for implementing the user registration. For that, first of all, open the terminal. First of all, let's create this parent user component. So here is the corresponding Angular CLI command, ng, g for generate, c for component, and we have to provide the name of the component, which is user. You could see the corresponding documentation here. Look for ng generate. The command for creating the component could be seen here. Now hit enter. You could see the newly created component inside this app folder. See, we only have two files, one for TypeScript and one for the HTML file. It's due to the initial configuration we have provided while creating the Angular app. No component specific start sheet and no test file. The specified configuration is saved into angular.json file and will be applied for every component that we create inside this Angular app. Now let's create this component for user registration. For that, we can reuse the previous command. Just use the upward arrow so you can see the previous command that we have used. This registration component should be placed inside this folder, user component folder, because it's a child component for this user component. So user/registration. Hit enter. So here we go. Now this login component will be created in next part. So I will just mark it as like this. Now let me create this auth service. So here we go, ng, g for generate, s for service. We want to create the auth service and we want to place this service class inside this folder directory shared/services. Hit enter. So here we have the new service class inside the specified folder path. We will be creating this pipe later. So that's all enough for now. Let's start customizing the app for user registration form. So let's start with app.component.html. I will replace everything inside this file. Instead, I want to show this parent component user. So you could see the corresponding selector here, app selector, app-user. So here we go. Let's create a tag with the selector like this. So currently inside the app, we have the default text from the user component. You could see the same inside this user component HTML here. Now before going forward with the customization, let me add the Bootstrap into this Angular app. So go to the official website, getbootstrap.com. From this home page, I will just copy this statsheet CDN reference. And let's paste that inside this index.html inside this head part here. And I also want to use the Google font for this app development. So go to Google font, then search for the font Indo, which is my favorite Google font. So here it is. Click on Get Font, then click on Get Embedded Code. Let's copy these link references and just paste the same inside this head part here. Now we want to apply this font for the entire application. So open the global stat sheet styles.css. Inside that, we will apply the font for the entire body of the HTML web app. Let me copy the CSS rule from here. Font family is applied as Indo and there is a backup sans serif. So that's all about adding Bootstrap and the Google font Indo into this application. Now back to the user component HTML. And let me detach this app preview and let's place it side by side with VS Code. Now inside this user component, we want to show this registration component here. For that, first of all, we will have the container from Bootstrap. Inside that, we will have the raw div. Now in order to render this registration component, we can add the corresponding selector that will be app-registration. Now here you could see an error saying that the app registration is not a known element because currently we are dealing with standalone components. So everything that we are going to use inside this user component should be added into this imports array here. So here we go, registration component. That's it. Now we are showing the default text from this registration component here. Now back to the user component again. Now I want to show this registration component inside a card-like element. For that, here we have an extra div having this class from Bootstrap rounded 4 to apply a corner radius. Let's set the border width to 0 and we want to apply a shadow and the background color will be white. Now let's move this component into it. Now at the same time, I want to apply a different background color for the entire body of the app. So back to index.html. For this body here, I will apply this Bootstrap class bg primary settle. Back to the user component. Now let's render this div. For that, I will apply the vertical height of this raw div to 100%. To align the containing child in vertical center, we can apply this class align item center. Now while developing this app, we may need to expand or decrease the width of this preview. So let me wrap this div with another div having the responsive classes. So here we go. Let's move this div into it. Okay, that's fine. Now let me set a minimum height for this div using the style attribute like this. Min height is equal to 450 pixels. Now we want to apply a padding before this registration component. So here we have another div having these clauses. And along with that, we want to apply 100% width. That's it. Now, in order to place this div at vertical center, we can add another wrapper div like this. First of all, we'll set the display to flex, and then we can set this justify content start. Now to center the containing div at vertical center, we can apply this clause align item center. So that's all about the surrounding wrapper for the registration form. Now we can design the registration form inside this registration component here. Let's create the form using Angular's reactive forms approach. You could see the detailed documentation here. Go to docs. Then inside this forms, you could see reactive forms. Here you could see the different ways of creating forms in reactive forms approach. In this video, we'll be using form builder from the reactive form module. So first of all, let's go to the component TypeScript file, and then we have to import this module, reactive forms module. And then we can inject the form builder to this class constructor. Public form builder, which is of the type form builder. Now with this form builder, we'll be creating an instance of form group. Inside that, we'll be defining properties corresponding to form controls. So here we have the form group object form. Now to create the form group, we can make use of this form builder. From that, we just need to invoke this method group. Into that, we can pass an object like this. Inside this object, we can add properties representing each of the controls. So first of all, we have full name of the user. Into it, I will just assign an array like this. So this first item of this array will be treated as the default value of this full name control. Now into this array, we can append various validations that we want to apply to this full name control. We'll do that once we implement the .NET Core Web API project. Now let me duplicate this for email, password, and confirm password. Now we can design the form using this form group object. So back to the component HTML file. So first of all, we have the form element. We don't need this action attribute. First of all, to this form element, we'll set this directive form group. Into that, we can assign the form group object that we have just created. Now, first of all, let's add the input control for full name. For that, first of all, we have this div having a bottom margin of the range 3. Inside that, we can have this input element having these bootstrap classes form, control, and with this class, we'll apply a background color bg body secondary. We don't need to explicitly set the type attribute as text. The default value is text itself. So let me remove this type attribute. Now here I will set the placeholder as full name. Now we have to bind this input control to this full name property of this form group. For that, we can make use of this attribute form control name, and we just need to set it as full name. Now let me copy paste this for email. The corresponding property is email. The placeholder will be email. Sorry, something is wrong with this text box background color. Yes, here we have a typo. Now let me copy paste this for password. The corresponding property is password. And let's change this placeholder. If you want to hide the characters entered into this text box, we can set the type of this input control to password. Since we are creating this project for demo purpose, I will skip that. Let me copy paste this for confirm password. Now finally, we have to show a submit button. So here we have the div having a top margin of the range 4. Inside that, we can have the button of the type submit. And let's apply these bootstrap classes btn, then btn success. And this button will be having 100% width. And let me modify the corner radius to this class. Inside that, we'll show this text register. So that's all about designing the form. Finally, let me add a heading for this form. For that, we can have this div having a bottom margin of the range 4. Inside that we can have an h2 element, and let's set the containing text color with this class text success. Inside that we'll show this heading sign up. Now let's implement the form submit event to ensure that all of these form controls values are getting posted properly. For that, we can make use of this event property ng-submit, and let's assign a function to handle the form submit event. So that will be on submit. Now we have to define this function inside this TypeScript component here. Now inside this form submit method, to retrieve the submitted form data, we can make use of this form group here. So here we go, we'll print the form data into the developer console. Using this form group, this .form.value will return the object having the values from these form controls. Let me save this, back to the app. Let's open the developer console. Let's populate the form with random data. Submit the form, boom. So here we have an Angular registration form ready to submit the user registration data into the ASP.NET Core Web API. So let's go ahead with creating such a Web API using ASP.NET Core Identity Framework. So without further ado, let's get started with creating the Web API project inside this Visual Studio 2022. So first of all, create a new project. Select this template ASP.NET Core Web API. I will name this project as Auth EC API. Click on Next. Then select the latest installed .NET version. Then I will keep this authentication type as none so that you will know how to implement it from scratch. Now since we have a demo project here, I will uncheck this HTTPS configuration. Then I will keep this feature OpenAPI support as it is. This feature allows us to make use of the Swagger tools for testing the various endpoints that we create inside the Web API project. Now click on Create. So here we have the brand new Web API project. Before we go any further with ASP.NET Core Identity inside this project, first of all I want to talk about Identity and Access Management, abbreviated as IAM. Throughout this series, I will squeeze in as much as prerequisites like this to make you familiar and comfortable with ASP.NET Core Identity. So in short, IAM ensures the right people or machine or software components get access to the right resources at right time. Now, when it comes to authentication or authorization, it might not be always a person trying to access a secured or protected resource. It could be machines, for example, robots, and it can also be a software component. Now assume that you have a client-side app in Angular or React, and inside that app, say you want to retrieve all of the Facebook groups that a particular FP user has joined. For that, first of all, this client-side app must be authenticated to the Facebook developer auth system. In this given context, instead of a person, we have a software component that is trying to access the Facebook API. Instead of a normal FP user credentials like password with email or mobile number, this software component should be passing a different credentials which is first registered into the Facebook developer system. So in this given example, the client-side app acts as a software component. So in short, the party that is trying to access the protected resource could be anything in this range: people, machines, or software components. So IAM ensures that the right party get access to the right resources at right time. In brief, first of all, the party must prove that who they are or what they claim to be. A process in which they have to prove they are an insider. This is what we call authentication. More about that will be discussed in next video. This process in layman term we often call as login or sign-in operation. Now let's go ahead with the next step. Even when a party is successfully authenticated into the system, proving that they are an insider doesn't mean that they have the full access to consume the entire resources inside the protected system. The party could be allowed or denied to access certain resources inside the system. Now, this process is called as authorization. More about that will be discussed in the third video of this series. So a solution that fulfills these requirements is globally known as Identity and Access Management, in short IAM. For .NET applications, these are the available identity management solutions. Among them, ASP.NET Core Identity is the commonly used identity management solution for .NET Core applications. Now let's get straight into ASP.NET Core Identity. Now before getting started, I just want to let you know that the official documentation of ASP.NET Core Identity could be seen under this ASP.NET Core documentation inside this section, Security and Identity. And make sure to select the right .NET version from this dropdown. You could see the link of this official documentation inside the video description along with other important resources that I have referenced for this entire series. Rest of the prerequisites could be discussed when the right time comes. So with that being said, back to the Web API project, and let's look what we have inside this default Web API project. So everything starts with this program.cs file. So first of all, we have a builder object returned from invoking this method createBuilder from this web application class. Inside the builder object, we have this service collection. Into that, we'll be adding services that we need inside this Web API project. And from the same builder object, we have invoked this build to return the app object, which is then used for configuring the services that we have added into the service collection here. Okay, you could verify that here. As you can see into this service collection, first of all, we have added the controllers that transform this application into a Web API project. Otherwise, this would be a plain C# console application. And then with this app object, we can configure the services that we have added here. So for example, we have called this method map controllers so that all of the endpoints inside the various web methods inside this application will be configured into this project. Similarly, we have added the services for the Swagger UI here, and the same is configured here. Along with all of these methods, we have invoked this method use authorization. We'll talk about that later. And finally, with the execution of this run method, the entire application will be made available to accept the incoming request. So that's all we have inside this project. Now it's time to add ASP.NET Core Identity into this project. We have already discussed what is an identity access management and what it does. So the same is applicable to ASP.NET Core Identity also. Now let's be specific about what it does. ASP.NET Core Identity includes APIs, UI, and backend database configuration. So basically it allows us to manage user identities, storing user credentials, and granting or revoking permissions. And we are planning to implement these features in this video series. Now as part of this first video, we'll be creating user identities as part of user registration. Now along with these primary requirements, it supports external logins, two-factor authentication, password management, account lockout and reactivation, and support for authenticator apps. So all of these features are made available by ASP.NET Core Identity to the outside world through the APIs here. We just have to consume them with the required data passed to it, which are basically web API methods. Now when it comes to a web application MVC, it also provides the front end with Razor pages, which I have already discussed in one of my previous video. Link will be there inside the video description under the heading related videos. And finally, we have the backend database configuration, which is basically Entity Framework Core models. So throughout this series, we'll be discussing how to make use of these services provided by ASP.NET Core and how to customize them as per our requirement to implement all of these features here. Now it would be more helpful if we understood the architecture of ASP.NET Core Identity in brief. We'll come to that in a bit. Before that, let's install the required NuGet packages into this web API here. For that, right click on this project, then manage NuGet packages. Then inside this browse tab, search for this package, Microsoft ASP.NET Core Identity Entity Framework Core. Throughout this series, the install NuGet packages name will be there inside the video description along with other helpful instructions. You just have to copy paste from there. Now let's install this Identity Entity Framework Core package. Now, since we are going to use SQL Server for this project, we have to install the corresponding Entity Framework package, which is Entity Framework Core.SqlServer. Let's install this. Now, finally, in order to execute the migration commands, we have to install this package, Entity Framework Core.Tools. So these are the NuGet packages to get started with ASP.NET Core Identity. Now let's add the corresponding services into this program.cs file, like this default project added the service for Web API controls. Now before doing that, let's get familiar with the architecture of ASP.NET Core Identity. So first of all, we have the data source layer for storing the data related to the entities inside the framework. In our project, it would be a SQL Server DB. Then we have data access layer. By default, it would be Entity Framework Core. And then just above that, we have identity store. It defines the structure and relation between various entities inside the identity solution. You could think of them as entity framework models, like users, roles, etc. All of them defines the ultimate structure of the table that is going to be created inside the data source. And then we have identity manager. For each entity we have inside the solution, such as user or roles, we have corresponding managers like user manager, role manager. So basically they consist of methods or handlers to implement the features that we talked about, like creating users, authenticating, authorizing users, etc. and etc. So these are the two layers that comes from ASP.NET Core Identity. Now in order to make use of them inside our ASP.NET Core Web API, we just have to add the corresponding services into our Web API project. So here we go, builder.services. First of all, we have to add this identity API endpoints. So this will add the various API endpoints from the identity core, which are handlers to implement various features that we talked about. Now while invoking this method, we have to pass the model class corresponding to the user entity. So that will be identity user. So by default, this is the class identity user, which defines what all things we need inside the entity user. So here you could see the default properties inside the user entity. We'll customize that in a bit. So first service is added here. So the service that we have just added is corresponding to this identity manager and the corresponding exposed Web API methods. Now let's add identity store. Let me zoom in a bit. For that, we can invoke this method add entity framework store. So these are the two services that we have to add to make use of the identity core. Now while invoking this method, we have to pass the class corresponding to the DB context that we are going to use to interact with the DB, which we have not yet created. So let me create a new folder called models. Inside that, we can have this class app DB context. Normally, in order to define a DB context class, we inherit this entity framework class DB context. In case of identity core or ASP.NET Core Identity, we have to make use of this DB context class identity DB context. Now this becomes a DB context class. Now let me copy this and let's pass the same here. So here we have done with adding services from ASP.NET Core Identity into this Web API project. Now using the model classes that we have inside this identity store, let's create the actual physical DB inside the SQL Server. For that, we can just continue with the DB context class that we have just created. Now first of all, let's add the constructor like we used to add in any entity framework called DB context. Now here we have the corresponding parameter DB context options. Now we have to specify the DB context class as app DB context. Let's name this parameter as options. Now along with this constructor, we also have to invoke the base constructor, which is the constructor that we have inside this parent class here. For that, we can do this base then options. Now in order to create the physical DB with the existing default entities inside identity core, we have to do the migration. Now by the way, these are the entities that we have inside ASP.NET Core Identity. For each of these entities, you could expect a SQL Server table. Now, before doing the migration, we have to inject an instance of this DB context class inside this program.cs file. So here we have the service. From that, we can call this method add DB context. Now, if you don't know how dependency injection work, we can explain that in brief in a bit. Basically, it is a process of creating an instance of this passed class here. So in order to create this instance, we have to pass the argument corresponding to this constructor parameter here. So basically, it is expecting a DB provider based on the DB that we are using. So we'll pass the argument using this lambda expression. All we have to do is from these options, we have to call the method corresponding to the DB provider that we are using. Since we are using SQL Server inside this project, we can invoke this method use SQL Server. Into that, we have to pass the corresponding DB connection string. So first of all, we have to save that into this app settings.json file here. So here we go, connection strings. Inside that, we'll have this key dev db. So this connection string is only for the development environment. So first of all, we have the SQL Server instance name, and we have the DB name, which is auth ecdb. And then we have these options. First of all, trusted connection is set as true. Now, in order to enable the encryption, we have set this option as true. Now, finally, in order to execute multiple query batches simultaneously, we have set this option, multiple active result sets. So that's all we have inside my DB connection string. Now let's pass this same into this use SQL Server method. In order to access the data that we have stored inside this app settings, we could make use of the builder object like this, builder.configuration. From that, we can invoke this method get connection string. Into that, we can pass the name that we have given for the connection string. Now we are ready for DB migration. Now before getting into that, let me briefly explain how dependency injection works in ASP.NET Core. So here we have injected an instance of this app DB context class. And here we have the default controller inside this app, weather forecast. Inside that, you could see this default web API method for a GET request. The instance of this class here, this controller class, will not be created as by manually. It will be automatically created by the ASP.NET Core framework when a request reaches up to this web API method here. So during the creation of such instances, if the corresponding class constructor is having a parameter which is of the type that we have injected here, then a corresponding instance will be assigned to the constructor parameter that we have here. Say for example, for this constructor, we have a parameter of the type app_db_context. When an instance of this controller class is created, an instance of this app_db_context will be passed because of this dependency injection here. We don't have to create the instance manually. So that's how dependency injection works. Now let's go ahead with DB migration. Before that, build the project. Make sure that there is no error. See, here we have a successful build. Now all we have to do is open the package manager console, which in my case it is inside this bottom portion of the Visual Studio. If you can't see it, select the project, then go to Tools, then NuGet package manager, then package manager console. Now for DB migration, first of all, we have to execute this command add migration, then provide a name. Let it be initial migration. Hit enter. As a result of this command execution, here we have a new folder called migrations. Inside that, you could see the C# file with respective SQL Server commands, which is to be executed to create the actual physical DB. Now, in order to create the actual physical DB, we have to execute this second command, update database. So here we have successfully done with the migration. If there is any problem in connecting with the physical DB, you could expect an error while executing this second command. So if there is any error, please recheck your DB connection string. Now in order to work with the database, I will be using the SQL Server Management Studio. Let's check whether the actual physical DB is created or not. So here we have the new DB. Inside that, you could see the tables corresponding to the entities that we have inside ASP.NET Core Identity. So these are the tables corresponding to the default entity framework core models that we have inside ASP.NET Core Identity. By default, all of these tables name will be prefixed with ASP.NET. Now let's check what are these tables stands for. So first of all, we have the table or entity user, which is having these properties or corresponding columns like username, email, password, phone number, etc. Then we have this role entity consisting of the collections of roles that we have inside our project, like admin, accountant, HR, etc. and etc. Then we have this user role, which is saying what are the roles assigned to a particular user. Now you can see this entity user claim and role claim. These are the additional informations that we can add to a user or a role. You will understand it better in the third video of this series. And then we have this user token representing the token assigned to a particular user. This will be helpful when it comes to token authentication. What is meant by token authentication will be discussed in next video. And finally, we have user logins. It represents or store information about user logins, especially when it comes to external logins like Google, Facebook, etc. So that's all about the DB part to get started with this project. Now back to the program.cs file again. So these are the services that we have added from Identity Core, including the various endpoints to make use of the handlers inside the framework. In order to add the respective routes into this application, we have to configure this app object like this, app dot. We have to call this method map identity API. Here we have to specify the model class that we use for the entity user. So by default, that will be identity user. Now let's run this app to see the various endpoints exposed from ASP.NET Core Identity. So these are the various web API methods or endpoints that we can make use of to implement the identity solution inside our project. Now the URL to this web API method will be like this, localhost, then this port number /register. Now since we are inside a .NET Core Web API, we have to prefix API just before this endpoint here. So API /register, API /login. In order to do that, we can do this just before mapping the identity endpoints. We can invoke this method map group, and inside that we can pass this /API. Let's build this project. See, that's it. Now in order to register a user, we have to consume this post web API method here, API /register. And it is expecting these data like email and password. Now if you only need these two information for creating a new user, you can make use of this post web API method. But in this tutorial, we also want to show you how to customize the identity as per your requirement. So in case of this user registration, along with these two informations, we also need the full name of the user. For that, back to the project. Now we'll create a new model class. I will name it as app user. Now we have to inherit this class from the identity model identity user. So along with the properties that is there inside this model class, we have to add this extra property for full name. Now let's specify the data type corresponding to the SQL Server column. So here we have the attribute column. Into that we can pass this type name. Let it be nvoc 150. Now you could see this green squiggly line here saying a non-nullable property must contain a non-null value. In order to disable this warning, just place the cursor inside this property, then expand this drop-down, suppress or configure issues, configure severity, click on silent. Now ASP.NET Identity recommends adding the data attribute personal data to all the properties which are related to personal information of the user. Now let's copy this user class from here and let's update the same wherever we have used identity user so far inside this project. You could see all of them inside this program.cs file. First of all, we have the mapping for the identity endpoints. And then we have mentioned the same while adding the services for API endpoints. Okay, let me save this. Let's build this project. Build is successful. Now let's do the DB migration again for the newly created property here, full name. So open package manager console. First of all, execute this command add migration. I will name it as name is added in user entity. Hit enter. Finally, we have to execute this command update database. Sorry, we forgot the important step, which is adding a reference of this app user class into this DB context class here. Because when it comes to Entity Framework Core, everything will get connected through this DB context class. So if a new model class is added to the project and which is not added here, and then it won't be considered in future DB migrations. So all we have to do is just define this property dbSet for the model class app user. Now this property can be used for interacting with the corresponding table. So I will name this property as app users. Let's save this back to package manager. Let's re-execute the commands. I will name this migration as second try. Update the database. Back to the management studio. Refresh the DB. Let's expand the columns of this user table. So here is the new column, full name. Now during the user registration process, along with these details, we also have to pass the full name. So instead of using this default web API method, we're gonna create a new post web API method for user registration. That we can do inside the program.cs file itself. Later, we can organize everything into respective files and folders. Instead of conventional controls like this, we're gonna use minimal API controllers inside this project. With this new minimal approach, it is really easy to create new web API methods and way more satisfying than conventional controls. So in order to create a post web API method, all we have to do is from this app object, we just need to call this method map post. So this becomes a post web API method. Now as a first argument, we'll pass the URL. It will be API/signup. And here we have the corresponding callback to handle this request. As per the current setup of Identity Core, there is no straightforward method to reuse this URL. And with the current version of the framework, we can't extend already existing implementation of the verb methods from Identity API. Could be made available in upcoming versions. So that's why we have created a separate URL here. Now talking about the actual implementation, hope you know that ASP.NET Core Identity is an open source project. You could see the actual source code inside the GitHub repository here. And if you want to see the actual implementation or source code of these identity web methods inside this project, you can search for this file, Identity API Endpoint Route Builder Extensions. Inside that, you could see the actual implementation of the web API methods that is available inside the project by default. So for example, if you want to see the actual implementation of the web API method, which is responsible for the registration of a user, here is the web API method. And for login, you could see the post web API method here. So like that, most of the web API methods that is exposed from the identity solution by default could be seen inside this file. Back to the topic. Now let's handle this post request inside this callback. First of all, we have this parameter user manager. Along with this manager, we also have to pass the model class for the user entity. That will be the new class that we have created, app user. We'll name this parameter as user manager. Now we need a second parameter to accept the user information that is passed through the body of this request. For that, I'm going to define a class like this, user registration model, after executing or invoking this run method here. Don't worry, we'll organize everything in next lecture. So this class represents the properties that we expect through this post web API method, email, password, and full name. Now let's add the second parameter accordingly. From the body of this request, we expect the properties that we have inside this class, user registration model, and we'll name this parameter as user registration model. from where do we get an instance of this user manager class? Now we need this user manager to do any operation related to user. In this case, we have to create a new user. We have already seen this class user manager while explaining the structure of the identity solution. Identity manager layer consists of these manager classes. We have already added the respective services with this method add identity API endpoints along with adding the entity framework stores. So an instance of this user manager comes from the dependency injection that is done with these two method invocations here. Like we have seen with the DB context class, the dependency injection is done here, and from there, all the classes having a constructor parameter of this type will be assigned or shared with an instance from the dependency injection that we have configured here. Similarly, the dependency injection done for the manager classes will share an instance for this user manager parameter here. Now let's go ahead with user creation process. First of all, we have to create an instance of the model class app user. First of all, we have email and we'll assign the corresponding value from the body that we have passed to this post web API method. Now similarly, we have to assign the full name. Now in order to create a user, all we have to do is from this user manager, we can invoke this method create async. Inside that we can pass the user object that we have created. Now as a second argument, we have to pass the password. That's why we have skipped passing the password into this app user object. Now let's pass the same from this registration model password property. Now since we have an async method here, we can prefix this method invocation with the keyword avoid. At the same time, you could see that this async keyword is automatically added here. Now we have to store the return object from invoking this method into this variable result. Now based on how this operation is carried out, we can return the response from this web API method. For that, we can have this if clause. If this operation is successful, inside the result object will be having a boolean property succeeded. It will be set as true. In that case, we can return the response like this. Results.ok method can be called. Inside that we can pass the result object. So this will return the response with a status code 2.1 indicating the user is successfully created at the web API. Else, we'll return the response like this. Instead of OK method, we'll invoke this method bad request. Now this is all we need for creating a new user inside ASP.NET Core Identity. Now depending upon your future requirements, you can extend this web API method. For example, if you want to verify the given email address from the user, you have to make the required changes inside this web API method. Okay. Now let me build this and let's create a new user. Now inside this Swagger UI, you could see the new post web API method that we have created, API/signup. Click on try it out. So first of all, we have the email address. For now, let's keep this password as it is, string. Then we have full name. Click on execute. You could see that we have got a response with the status code 400, meaning that a bad request is sent from our client side here. So here we have the response body having succeeded property is reset as false. To see the actual problem, you could inspect this errors array. So basically these are the errors or validation errors for the password that we have passed. So by default, the password must have at least one alphanumeric character, meaning that there should be at least one special character inside the password, then at least one digit, one uppercase. Now if you want to keep these validations as it is, you can do that. But if you want to customize these validations, you can do that also. So inside this program.cs file, with this builder object, we could do this builder.services.configure method can be called. And here we want to configure the identity options. This collection of services can also be used to configure like we configure with the app object here. Along with adding services, it will also be used for configuring the added services. So here we go. We have this lambda expression with this options parameter. options.password. Inside that, you could see the various validations applied to this password property. So first of all, I want to disable this validation for required digit. Let's duplicate this. Let's disable the validation related to the uppercase and lowercase requirements. Now, along with all of these, I want to enable a new validation. It goes like this: options.user. Inside that, I want to set this require unique email as true. By default, it is false, so no user can have same email address. Okay, so with that being done, let's build this project again. Let's try to create a new user again. Now let's specify the password. Now, by the way, these are the default validations applied to the password property. Required digit, which we have already disabled. Then we have the min length validation. At least there should be 6 characters. Both of these validations, lowercase and uppercase, are already disabled. And we have to keep this at least one special character requirement. And finally, you could see this unique character validation, which at the moment is set as 1. So technically it is disabled. Now suppose if it is assigned with a value more than 1, say 2, then passing a password like this, repetition of same character is not allowed. There should be at least 2 distinct characters. So that's what this validation implies. When it is set as 1, technically it is disabled. So at present, we have these 2 validations, minimum 6 characters, and there should be at least 1 special character. So here we go, string, then I will add this special character. In total, we have 6 characters. That's enough. Now let's provide a full name. Click on execute. Now you can see another error here, saying that username is invalid, can only contain letters or digits. Now, as per the default identity model implementations, the username can't be blank. For this particular identity solution, we are not asking for the username. Nowadays, most of the application is not asking for username. Instead, they use email address. If you have such a requirement where username is required, you can pass that and do the required changes inside the web API method. Okay. Now, in order to disable this error, we often pass this same email address into the username property. Now, before making the changes inside the web API, first of all, let me copy this object to the clipboard. We'll need that for the next try. So here we go. Along with passing the email, we'll pass username with the given email address here. So that will solve the problem. Save this, build the project, back to the Swagger UI. Making changes inside the web API will reload the page, and that's why we copy the last user object. Click on try it out, and let's paste the same here. Click on execute. Boom. So here we have successfully created the user inside the ASP.NET Core identity. Let's verify the same inside this user table. See, here we have the new user with given credentials. You won't see the password that we have passed. Before saving it, it will be hashed into a format like this. Now let's head over to VS Code and let's make a post request inside the form submit event to consume the web API method that we have just created. Now, before making the actual post request, we have to implement all the validations that we have inside the web API endpoint to the Angular registration form also. Okay. I think we have to change the responsive classes that I have applied inside the parent component here. User component, instead of XXL, let's start applying this class from LG itself. And let's change this to MD8. And let's change the offset accordingly, MD-2. Okay, that's fine. Now back to the registration component. Let's implement the validation. For that, back to the component TypeScript file. First of all, we want to set this full name control as required. For that, we can pass the validations from the second element of the array here. So validators dot required can be passed. The same required validation is to be applied for rest of the controls, so email and password. Now for email, we want to verify the correctness of the email format. For that, we can pass this validation validators.email. Now when we have multiple validations like this, we have to pass them as an array like this. Now for password, we have multiple validations. In order to pass them, we have this array here. Inside that, we already have the required validation. Now let's apply the min length validation. So validators.min length, there should be at least 6 characters inside the password. And finally, the password must have at least one special character. So we can implement the validation with regular expression like this. We just need to invoke this method pattern. Inside that, we can pass this regular expression. The character must be outside English alphabets, digits, and white space. Now, apart from these given validations here, we have an interdependent validation to match this password to this confirm password value. So we have to apply the validation on this form group level. So as a second parameter to this method group, along with passing this object, we can pass an object like this. Inside that, we can make use of these validators. For the particular validation requirement, there is no built-in Angular validator. So we have to do it on our own. For that, we can pass a function to this validator property. Password match validator. Now let's define this method here. This method should be implementing the interface validator function from Angular. This interface is imported from Angular forms. Now here we have the function. The function is having a single parameter control, which is of the type abstract control. Now there is nothing to return from this function, so I will set the return type as null. Now here we have the function implementation. Now as you can see here we have an error saying that the method is used before its initialization. So let's move this function from here to here. Now at the end of this method, we have to return null. Now first of all, we have to retrieve the object corresponding to these form controls, password and confirm password. So here we go. For that, we can make use of the control parameter. From that, we can invoke this method get, and inside that we can pass the name of the property password. Let me copy paste this for confirm password. Now here we have the if clause. Inside that, we have to verify that there is a value for these control objects. So here we go, password and confirm password. And then we can compare the containing values like this, password dot value. If it is not equal to confirm password value, we'll set the validation error. For this control, confirm password control, we will set the error using this method set errors. All we have to do is we'll pass an object with this property password mismatch. We'll set it as true. Else we can clear the errors. For that, let me duplicate this and let's pass null here. Sorry, here we have a warning that this method invocation here is deprecated. It's because here we have a typo while passing the validators. So use small letter v. So this is how we can implement interdependent validations in Angular 4. You could see the detailed documentation of this validator interface inside the official documentation here. Just search for validator function, and here we have the API reference. The function must have a parameter of the type abstract control. So that's what we have here. From that, using this method get, we can retrieve all of the objects corresponding to each of the controls that we have inside the form group. And using the control object, we can compare the values inside the controls, and then we can set the error like this. Inside the documentation, you could see that the method must be returning an interface of the type validation errors. Inside the description, you could see that this function receives a control and synchronously return a map of validation errors if any error is present. Otherwise, it should return null. Now inside our project, we have returned null. instead of validation errors. If you return validation errors, the errors will be there inside the form group object here. Instead of that, we want to assign the error to this particular control confirm password. So that's why we have invoked this method set errors, and from this method we always return null. So hope you understood how to make use of custom validation in Angular forms. Now let's show the validation error messages along with the respective controls. So back to the component HTML file. First of all, we have full name, so we'll add this div having this class error feedback. We only want to show this div if there is any error related to this required validation of this full name. So here we have the ngIf directive, ngIf. Inside that we can specify the condition. From this form group object, we can retrieve all of the controls using this property. Inside that we have this property corresponding to the full name control. Now using this method has error, we can check if there is any error related to the applied required validation. If there is such an error, we can show this error message, please enter your full name. Now this is a custom class to highlight the validation error feedback, which is not there inside the Bootstrap, so we have to add the corresponding CSS rule inside this global style sheet here. Now back to the form. Now along with this ngIf directive, you could see the error for not importing the common module. You can import the module inside this component level inside this imports array here, like we have imported this reactive forms module. Common module. Back to the component HTML file. Now you could see the validation error for the control full name here. Please enter your full name because at present this full name control is having the required validation error. If you populate the control becomes valid and there is no validation error. Now instead of showing this validation error in a fresh form like this, we have some criteria to be satisfied before showing this validation error here. To define the criteria, I'm going to define a function inside this TypeScript component here. So here is the function has displayable error. For this function, we only have a single parameter control name of the type string. And from this method, we'll be returning a Boolean value. Now let's define the criteria inside this method. Before that, I'm going to create a Boolean property inside this component, which is submitted, which is of the type Boolean. By default, its value will be false. So this property tells whether this form is already submitted or not. Now we have to set this property to true inside the form submit event here. Now back to the function. First of all, I'm going to create a property control. Inside that, we will save the object corresponding to the object for the given control name here. That we can retrieve from the form group object form. From that, we just need to invoke this method get. Into that, we can pass the control name. Now from this function, we are going to return a Boolean expression saying whether we want to show the validation error for this given control or not. First of all, this control must be invalid. That we can check using the control property invalid. As you can see here, this property can have a Boolean value or undefined. So we have to convert it into a Boolean value. So we will just wrap this property with the Boolean constructor. So this is the first criteria. So the control must be invalid. So that's the first criteria. Along with that, it should meet any of the following criteria. Either the form is submitted or the control is touched. This touched property will be set as true when user engage with this control here. So even placing the cursor inside the control will be treated as an engagement with the control. So this validation feedback will only be shown if this criteria is met. So here is the condition. If the control is invalid and either the form is submitted or the user is engaged with this control, then the validation feedback will be shown. So let's invoke this method has displayable error inside the component HTML here. We can do that inside this ngIf directive here. We'll invoke the method has displayable error. Inside that we can pass the control name. So that will be full name. Now inside this fresh form, the validation error feedback of an input control will not be shown unless the form is submitted or the user has engaged with the control. Now we have to do the same for rest of these controls. For email, we have two validation requirements. It should be required and it should have the correct email format. So here we go. Let me copy paste this div for email. Now let's check whether we have displayable error for the email control. Then only we'll show this div. Now since we have multiple validation, we can add extra child divs like this. So this div will only be shown if there is a required validation. So let me copy paste this ngIf directive. If the control is having the required validation error for this email control, we will show this div here. Inside that, we can have this feedback. Please enter your email address. We can remove this condition from the parent div. Now, if the control value is having incorrect email format, we can show the error message in another div. So let me copy paste this div. This time we are looking for email pattern error. So inside that, we'll be showing this. Please enter a valid email address. Now for password, we have three validations. The control is required. There should be at least 6 characters. And we have enforced at least one special character with this regular expression. So I'm going to copy paste this div of email for password. First of all, let's check whether we have an error related to the control password. Now first of all, if there is a required validation, we will show the error inside this div. Please enter your password. And if there is any error related to min length, at least 6 characters required. And finally, for the pattern, I'm going to add one more div. For that, we can check if there is any error related to the given pattern. So inside the div, we'll remind that there should be at least one special character. Let me save this and let's check how it works. We have already tested the full name. Email is required. So here we have the required error. Now if the user provides an invalid email format, you will get the pattern error. Enter a valid email address. Now for password, the control must be required and there must be at least 6 characters. Right now, as you can see, multiple validation errors are shown here. Most often when a control is having multiple validation error feedbacks, we prefer showing one validation at a time as a kind gesture towards the end user. So this is what I'm gonna do. Inside the app structure, I have shown you a pipe. First key pipe. Let's create that now. So here we go, ng, G for generate, P for pipe. You want to create that inside the folder shared pipes first key. Hit enter. So here we have the new pipe first key. Now the implementation of this pipe could be discussed in a bit. If this is the first time you are using Angular pipe, don't get frightened. We'll explain in brief how it works. Now let me show you how to make use of this pipe for implementing the validation requirement that we have. Back to the component HTML file. As you know, each of these divs here represent the error feedback of each validation that we have applied to the password control. Now in order to display one validation at a time inside this password control, we'll make use of Angular switch directive. You could see the detailed documentation here, ng switch. Look for built-in directives, so here it is. So inside this parent div, I'm going to add an ng container for the switch. So here we go, ng container. Now here we have the switch directive, ng switch. Into that, we have to pass the errors from the control password. So password.errors. This switch directive will work as exactly like the conditional statement switch from any language. Now let me move these child divs into this switch container. Instead of ngIf property, we want to use ng switch case. So this is corresponding to each of the case in a switch conditional statement. Now into this switch here we have passed an array of key value pairs. Instead of that, we want to pass the key name of the first error from the collection. The key name will be the name of the validation criteria, so it would be any of these: required, min length, and pattern. For that, we can make use of the pipe that we have created here. So first of all, we have to import this key inside this component TypeScript file here. Back to the component HTML. Now we can use the pipe here like this. Along with these arrays, we'll use this operator, single or operator. Then we can pass the pipe, which is first key. You could see the detailed documentation inside this templates, then pipes. Actually, you could think of this Angular pipe like a real pipe. For this pipe, here we have the input. And what this pipe returns on the other end will be assigned to the switch directive here. Now what this pipe returns depends on its implementation. So basically the class for the pipe must implement the interface pipe transform. And this name that we have given here should be used inside the HTML file like we have done here. Now this transform function decides the output from this pipe. Now as I told you, what we have before this or operator will be taken as the input for this type here. So these errors will be of the type validation errors. So basically it's a key value pair. So the same could be received with this parameter here value. Now in order to make use of this pipe globally for any key value pairs, I will change the type of this parameter to any. And we don't need this second parameter here. Now from this method, we'll either return a string or null. We'll be passing key value pair to this function, and from this method we'll return the first key pair key name. So first of all, here we have the property keys. Into that we'll assign the keys from this object. So we could do this object dot keys. So this will return an array of keys inside the object value. Now with this if clause, we will check there is at least one key. If that's the case, we'll return the first key. Otherwise, it will return null. So the key that we are returning here is the name of the validation error, like required, min length, pattern, etc. So with this switch case, we are going to equate the value first key with required. We have to enclose the value inside single quotes. Now here we have min length. Now here we have to equate it with pattern. Now you see, first of all, we have the required validation, then min length, and if it is met, then we have the special character error. Boom, that's it. So that's all about the password. Now finally, we want to show the validation error for this confirm password. For that, I can copy paste the div of this full name validation error feedback, copy and paste the same here. So first of all, we will check whether this control is having a displayable error, and we will check if there is any error related to the validation that we have given here. Let me copy the key from here, password mismatch. So if the control is having this validation error, we will show this error, passwords doesn't match. Let's try the same. Now we have to pass the same into this confirm password. Otherwise, we will return error like this. See? So here we have done with the client-side validation for this registration form. Hope you have learned all about validating controls in Angular. Now let's go ahead with submitting this registration form and passing the form data to the web API method that we have just created, this one. So back to the component TypeScript file. Here we have the form submit event. First of all, we will check whether the form as a whole is valid or not. For that, we can make use of the form group. From that, we can check this property valid. Then only we'll post the data to the web API method. Now, like I have already mentioned, in order to make the HTTP request to the web API method, we'll make use of this auth service. So here is the service, auth service. Now, in order to make an HTTP request, first of all, we have to inject HTTP client class. To do the injection of the HTTP client, first of all, we have to go to this app.config.ts file. Then inside this providers array, we have to invoke this method provide HTTP client. Now, back to the auth service. Now we can receive the instance of the HTTP client like this. Inside the constructor, we'll create this parameter HTTP of the type HTTP client that we have just injected. Now, let me create a property to save the base URL of the web API. So here we go, base URL. Let me copy the URL from here. Along with this, we have to append API. Now I'm going to make a post request to this web API method here, API/signup. For that, I'm going to create a method here, create user, having a single parameter form data of the type any. So this will be the form data object submitted from this user registration form. Inside that, to make a post request, all we have to do is from the injected HTTP instance, we can invoke this method post. So this will make a post request. As a first parameter, we have to pass the URL. So along with this base URL, we'll append /signup. As a second parameter, we have to pass the form data. Now this method will return an observable as you can see here. Now from this service method, we'll return the same observable like this. Now we can inject this auth service inside the component TypeScript file. By default, all of the Angular service classes can be injected anywhere inside the application because of setting this property provided in as root. So back to the component. Inside the component constructor, we can receive an instance of the service class like this. Private service, which is of the type auth service. Now, from the form submit event, we can invoke the method that we have just created inside the service class. So here we go, service.createUser. Into that we have passed the form data. Now, as you know, this will return an observable, so we can make the subscription here, subscribe. To pass the error and success callback, we can pass an object like this. We can handle the success callback inside this next callback here. Now here we have the success callback. If anything went wrong, we can handle that inside this error callback here. Here we'll just print the error object like this. Inside the success callback, we'll just print the response. Now the web API is already running here. So let's make the post request from this Angular client. First of all, fill in the form with valid data. Submit the form. Let's open the console tab. See, here we have an error saying that this HTTP request for the web API from this Angular app has been blocked by CORS policy. Actually, this is much expected. As you can see from this error, it's because of the CORS policy. CORS stands for Cross Origin Resource Sharing. By default, any web API framework will block a request from a different domain or different port number. In this case, we have different port numbers. So first of all, inside the web API, we have to configure the CORS policy in order to accept a request from this Angular app. So back to the web API project. Then inside this program.cs file, we could enable the CORS policy for the particular Angular app. So all we have to do is just invoke this method use CORS from the app object. And it must be invoked just before invoking the use authorization method like we have done here. Into the method, we can pass a lambda expression like this, specifying the configuration that we have for the CORS policy. From this options parameter, we can invoke this method with origins. Into this method, we have to pass the URL of the Angular app. So let me copy this and pasting the same here. Make sure to avoid this / at the end. Okay. Now we have to allow all of the web API methods like get and post. For that we can invoke this method allow any method, and we also have to invoke this method allow any header configuration for the request. Inside this web API all we have is everything related to ASP.NET Core Identity. So I'm going to enclose this configuration of the course inside a region like this. Config course. Okay, that's it. Let's save this and build the project. Now we should be able to make the post request without any error. Now before trying submitting the form again, let's advance further inside the success callback of the HTTP post request. Now if everything goes well, the succeeded property inside the response will be set as true, which we have already seen while testing the web API method. So here we have the if clause. If the property is set as true, succeeded. In order to read this property from this response parameter, we have to set the response type as any. So if the user registration is successful, first of all, we want to reset this form here. For that, from the form group, we can invoke this method reset. And then we also have to reset this property is submitted, because the property is an indication saying whether this form is a fresh form or not. Since we have reset the form, it's a fresh form. So we have to reset the property is submitted as false. Now in addition to this, I want to show a notification saying the user registration is successful. For that, we're going to install this npm package ngx toaster. Let's copy this installation command. Let's open the terminal, paste the command, hit enter. So here we have successfully installed the package. Now how do we want to configure the package is mentioned inside this npm page here. We have already installed this package. Now we also have to install this package Angular/animations, which is already there by default inside the Angular app. You could check that inside this package.json file. Then after that, we have to add the CSS file into our Angular app. That should be done inside the angular.json file. So let's copy this style sheet reference. Then open angular.json file. You see here we have to add the style sheet reference into the styles array. So what I'm going to do is I will search for the array styles. Now let's paste the path of the style sheet here. Now actually there will be two arrays with the same name styles, one for production, one for the actual build. So we could find that through this find utility itself. So here it is. Let me paste it here also. Then next we have to add the toaster module, or we have to inject the toaster provider. Since we are dealing with standalone components inside the app, we could invoke this method provide toaster inside this file here, app.config.ts file, exactly where we injected the HTTP client. So here we go, provide toaster. Now the toaster service is available inside our Angular app components. So back to registration component. Inside the constructor, we can receive the toaster service like this, private toaster, which is of the type toaster service. Now wherever we want to show the toaster notification, we can make use of this toaster service. Now if the user registration is successful, I want to show a success notification. So I will do this. Toaster.success method can be called. As a first parameter, we can pass the notification message. As a second parameter, we can pass a title. So here we go, registration successful. If anything goes wrong, we will print the response like this. Now let's try submitting the form again. Before that, it's better to restart the Angular app, because for configuring this toaster service, we have made changes outside the src folder, which is inside this angular.json file. So it's better to restart the server. So open the terminal where we are running this Angular app. To stop the server, use this shortcut Ctrl+C. Let's clear the previous entries. To start the server again, we can re-execute this command ngserve-o. Let's try to submit the form with random data. Submit the form. No notification is shown. Let's open the developer console. Actually, I think the record is inserted and currently this error is from the toaster service. You could verify that inside the DB. Let's rerun this select statement. See, here we have the newly added user. So this error is from the npm package toaster. Later, I found that it was my mistake. Along with adding the toaster service, we also have to add the providers for animations by invoking this method provide animations. So let me copy this, then back to the app, open app.config.ts file, and let's invoke the method here provide animations. You know what? Instead of this version, I will go for the async version here. Okay, let me save this. Back to the app, reload the page again. Let's try with another user. Submit the form. Boom. See, here we have the toaster notification. Let's re-execute the select star statement. So here we have 3 users. Make sure all of the data are properly entered into the table. Sorry, I was trying with random data. So it would be difficult to verify whether we have saved the same data that we have passed from our client side. So what I'm going to do is, I'm going to delete everything inside this table like this. Delete from user table. And let's create a new user. You know what? Before trying that, let me change the position of the toaster notification. By default, it will be shown inside the top right corner. Instead of that, we want to show them here, top center. We can configure that while adding the provider itself. You could see the detailed documentation here. So this is what I'm going to do. While invoking this method provide toaster, we can pass an object with this property position class. Inside that, we can pass this particular class toast top center. You could see these classes mentioned inside this configuration here. See, position class. So save this, back to the app. So here we have the user Eva Elliott. This time we are trying with proper details. Email will be email@gmail.com, password, string, then hash. Submit the form. Boom. Let's verify the same inside the DB. See, here we have the new user for Eva Elliott. You could see the same email address that we have passed here. Now finally, we have to do one more thing. There are some validations that can only be done at the server side, like duplicate email address. To show you the same, I'm gonna submit this form again with the same email address that we have used for previous user. So first of all, let me open the developer console. So here we go, email@gmail.com. Submit the form. See, we have got a 400 bad request and here is the details. If you expand the errors, you could see the error details, duplicate username and duplicate email address. This is the proper one, duplicate email. Since we have saved the same email address into the username, we have the same error from that field also. So in order to consider these server-side validations, let's modify this form submit event here. Inside this else block, we'll be having a for each loop like this. Response.errors contains all of the errors that is returned from the server side. Now let's loop through them using this for each method. Inside that, we have this callback with a single parameter x, which is of the type any. Now with this switch case, we can check each of the errors that is returned from the server side. Now in the previous duplicate error we have seen, there was a property inside the error like code. So that's what we are going to match within each case here. So if the error code is duplicate email, we will show a toaster notification. So here we go, toaster.error method can be called so that a red notification will be shown. And here we have the message, email is already taken. And here is the title, registration failed. Finally, we have to add this break statement. Now, whenever this happens, we'll also get the error for duplicate username because we are saving the same email address to the username field also. So in order to avoid that, we could do this. If the error code is duplicate username, we will just break from the current iteration. So like this, you can customize the notification for server-side errors. Now, if the error code is none of these, we can have this default case here. Let me copy paste this error method invocation. The error message will be something like this, or contact the developer. Now, along with that, we'll print the error object to the developer console. So just print the X object. Finally, here we have the break statement. Let me save this. Back to the app. Let's try the same again. email@gmail.com. Submit the form. It didn't work as expected because the errors object is having a parent property error, which we haven't mentioned inside the code. And there is one more thing. We have to do this switch comparison inside this error callback here, because if the user creation fails from the web API endpoint, we are returning a bad request containing the error details. So that will end up in an error response. So that will be called inside this error callback here. So first of all, the errors object is the inside this parent property error. So let's correct that here. Now let's move this for each into the error callback. Now we have to look for this error inside this error parameter. Now actually we don't need this else clause inside this success response. Now inside this error callback, we'll only loop through this array if this object is present. So first of all, I will check if it is present or not. Otherwise, we want to handle this error inside this else block here. We'll just print the error object like this. Let's save this and back to the app, and let's do the same again. Submit the form. Boom, that's it. Email is already taken. Finally, before winding up this tutorial, I would like to give you a bonus tip regarding validation. If you enter invalid email address into this control, the validation error will only be shown if you disengage with the control, because at present the criteria for displaying the validation error feedback is determined with this function here, has displayable error. So the control must be invalid and either the form must be submitted or the control is touched. Currently, this error feedback is shown because the value of this touch property is set as true. And that will only happen when we disengage with the control. For example, if you pass an invalid password, the error feedback will only be shown if you disengage with the control. See, if you want to show the validation error even before disengaging with the control, you can do this. Along with checking whether the control is touched or not, we could check whether this property dirty is set as true or not. So this property dirty will be set as true when we change the default value of the control. If the control is having the default value, then this property pristine will be set as true. So these two properties are quite opposite. Now for an invalid control, even before the user disengaging with the control, if the user change the value of the control, we will show the validation error. See? So that's it guys, we have discussed everything related to user registration using ASP.NET Core Identity Framework in an Angular project being the client side, and in the server side we have an ASP.NET Core minimal web API. Now as a next step, we have to implement user authentication using a login form. We'll do that in the next video. You can download this project from the GitHub repository link given below in video description. If you found this video helpful and if you want to get notification when I upload next videos, please consider subscribing the channel if you haven't yet. Please like and share this video with your friends and colleagues so that they can also benefit from this. Have a nice day. Bye.